Hello everyone. Now this is another BGCSE past paper review. We're doing a biology paper, and this is an alternative to practical, which is a paper 5. And so paper 5 will take the place of the coursework. And this is for candidates who might have, for some reason or the other, could not do the physical coursework itself. And so this is a sample from 2016. Again, like all papers, please remember to write your school number, your candidate number, your surname, and your initials. Very important to do so. Also, read through the instructions carefully before you start the examination, and you need to follow all the directives given by the examiner. Now, let's go into our first question. And the first question reads that partially permeable dialysis tubing can be used in experiments to study absorption of nutrients or nutrient molecules across the wall of the small intestine. Now, the apparatus below can be used to determine whether starch or sugar can be absorbed across the wall of the small intestine. The apparatus is left for 1 hour before testing the water for the presence of sugar and starch. And just to point this out at this point is that this paper also try to test their 4 skills, which is your skill A, your skill B, your skill C, and your skill D. All right, so let's continue with this. So now you will see in the dialysis tubing, you're seeing the starch and the sugar mixture within the dialysis tubing, and then the water on the outside. The first part of the question asks us to explain the meaning of the term partially permeable. So what is meant to be partially permeable? Now, partially permeable means that the membrane, so the membrane, let me change this into blue. So the membrane allows only certain size particles to pass through, okay? All right, so partially permeable or semi-permeable, which means the same word, it simply only allows certain size molecules to pass through. So the smaller molecules will pass through, the larger one will not be able to pass through. All right, and so it says state one reason why each of the following procedure is necessary. So one, which is, it said washing the outside of the tubing in distilled water after filling with the starch and sugar mixture. So the reason for doing that is to remove any residue. So let's put that in real quick. So this is to remove, go up a little bit more. So to remove any possible residue. All right, so remove any possible residue that may give false results, okay? All right, so that's the purpose of rinsing the tubing in distilled water, okay? All right. All right, now let's jump into the next question. Now the next question reads, leaving the dialysis tubing for at least 1 hour before testing. So why do you want to leave it for at least 1 hour before testing? And the reason for this is really to allow effective movement or diffusion, let's say movement or diffusion of molecules. So if you do it immediately, the molecules may not get enough chance to diffuse across properly, because remember that molecules will have to move from area of high concentration to low concentration and so on, and not given enough time for the apparatus to allow the movement or diffusion, then you may not get any result at all. Now for this question which is part C. Part C states after 1 hour, 2 centimeter cube of water was removed from around the boiling for the boiling tube and tested for the presence of sugar and starch. Now it's a complete the table below, and this is a 4 mark. And so here it asks now to the substance tested for, how the test is carried out, and the last column asks for the appearance if the result is positive. And so Benedict Solution uses test for sugar. So this is used to test for sugar. Let's go by row. And how do you test for sugar? You will add the solution. All right, so simple as add the solution. Let's put it as points. So you want to add solution. All right. And after you add the solution, the next thing you want to do here is to shake. All right, so you will shake the apparatus. So shake, and then you want to heat. Okay. So that's the step you do. You add the solution, shake the test tube for a few seconds, and then you apply heat to it. And then the appearance, if it's positive, you might see red. You might see also brown, or you might see even, let's put this back up a little bit. So brown or orange, okay? So let's put orange there. All right, great. All right, so those are the color changes that you might see if sugar is present. Now, iodine is used to test for starch. And how do you test for starch in terms of the method? You simply just add the solution. So let's put that here. Add solution. And the next thing you want to do here is just to simply observe. So after adding solution, you want to observe. And then if it is present, what you'll see here is blue-black, a blue-black color or simple black. Okay. All right, great. Now for part D is a state which of these tests would give a positive result when the water outside the tubing is tested. And so for this part here, because the sugar molecules are smaller than the starch molecules, then the sugar will more likely pass through, and then you see a positive test for the sugar. Again, it asks you to give us the reason, so let's give a reason right here. And so you will not see starch in the water because starch is the starch molecules. Okay, let's say the starch molecules right there. So the starch molecules are too large to pass through. Okay, so to pass through the tubing. All right, so only the sugar you'll be able to see, because again the sugar molecules are smaller than starch molecules, because remember that starch is a complex sugar, which is a polysaccharide. All right, and again this also applies to the question asked above in terms of being selectively permeable, and so the tubing is only permeable to sugar but not to starch. Okay. All right, so let's jump to the next question, question number 2. And this one, so the diagrams show 3 leaves, each drawn to scale. And so they draw them to scale. And so the first question here asks us to measure the length of each leaf and record them in a suitable manner. And so if we're going to record the length of a leaf, what you want to record the leaf from is from the apex, which is the tip of the leaf right there. So you measure from the apex onto the base right here to where the petiole begins. So this will be the petiole. So from the petiole pretty much to the apex, okay? Just to make a note of that. And so you want to take your measurement starting from here and ends right here, right? And so I have measured these already, and get my markings and my measurements. And so I'm going to get into the answer for A, B, and C. And so for leaf A, it measures 5.5. This will be 5.5, and this is in centimeters. Leaf B is 4.5, and this is centimeters. And then leaf C is 3.5 and 3.5 centimeters. Okay, so that will be your 3 measurements. And then for part 2, so calculate the average length of the 3 leaves, and so the average length for the 3 leaves, you add up all the things, so the sum of the total, okay, so going to be 5.5, okay, plus 4.5 plus 3.5, 3.5, 3.5, and then that will equate to something, so it's going to be, this will be equal to 13.5. All right, let's put this all over another number now. Let's put this all over 3. So divide it by 3. And so 13.5 divided by 3 will also give you a certain number. And so this will give us 4.5 as our average. So 4.5 is our average, so 4.5 centimeters. Okay. All right, so let's put a line through it so you won't be confused in terms of what I did. So again, is the total over the number. All right, so it'll be 13.5 over 3, and that will be over 4.5. Okay, awesome. All right, so that will be your calculation right there. All right, let's now jump into the next part of the question. And the next part of the question reads, it said that leaf A was placed in dark cupboard for 2 days, while leaf C was left on a sunny window, sunny windowsill for 2 days. Both leaves were still attached to a growing plant. Afterwards, both leaves were tested for the presence of starch. Right here now it asks us to outline the steps involved in the process of testing a leaf for starch. Use the number 1 to 5 with 1 indicating the first step and 5 the last step. All right, so the first thing I'm going to do here, so let's call this our step 1. So step 1, what you'll do here is to boil the leaf. You want to boil the leaf here for approximately 30 to 40 seconds, okay? So 30 to 40 seconds, okay? That's the first thing you want to do. All right, so for step 2 now, step 2, what I want to do for step 2 is to boil the leaf in alcohol, okay? So to boil the leaf in alcohol in a water bath. So make sure you put this in a water bath, because you do not put alcohol directly over the flame, because it is flammable and it can cause fire, okay? So step 3. And for step 3 here, you're going to soften the leaf. In warm water. So you're going to place it in warm water again, okay, to get the leaf softened. Because once it's boiled in alcohol, the leaf will be very stiff, okay? And you also need to know the reason why you have done this. Okay, so the alcohol will take away, matter of fact, to boil the leaf first is to make it permeable and the membrane soft. The alcohol will take away the chlorophyll, and you make the leaf soft again, so it can be penetrated by the iodine. So our step 4 is to add a few drops of iodine. Okay, so add a few drops of iodine solution. And then the 5th and final step, what you do is simple, just to observe a color change, okay? Observe for color change. All right, so that will be your 5 steps, and pretty much you only get marks for 4 steps. The first 4, the boiling alcohol, softening the leaf, then add the drops of iodine. 4 marks. All right, so let's go to our next part of question right here. So predict the result that would be observed for each leaf after being tested for starch. And one thing I want to quickly remind you, remember that leaf A was placed in the dark cupboard, and leaf C was placed on the windowsill where it was bright. So let's go back up there real quick to remind you about that. Okay, so leaf C was left on the windowsill for 2 days, which was sunny, so get enough light. So since leaf A was placed in a dark cupboard, all right, for the 2 days, then you have no change taking place, and no change because what you'll have, the iodine will remain yellowish brown, okay? So what you see here is a yellowish brown color because that's what the iodine is. Okay, so a yellowish brown color, you will see no change in color at all. But for leaf C, since it was able to photosynthesize and make sugar and eventually form starch, then what you'll see here, it will move from a yellowish brown. Okay, so it move from yellowish brown to blue black. So that's what you actually will see, to blue black. All right, so the final color there will be blue black. So move from a yellowish brown to blue black. All right, so let's go to the next question. All right, and so for this question now, it said that some students decided to investigate growth in humans by recording the height of males and females at different ages. Their results are shown in table 1 and table 2. So table 1 is for males, the number of height for males at different ages. And then table 2, let's go to table 2. And table 2 is the height of females at certain age as well. Now for A, it said what is the height of the shortest student? And the shortest student here, look through numbers. The lowest number you have here right here is on the male, which is 142. So let's highlight that. So the shortest male, the shortest height here is 142. Let's go down to the question. So the shortest height of student here is 142. Okay, 142. The next part of the question asks now is to state the age and gender of the tallest student. So the tallest students, let's just scroll through real quick and see what number we get as the tallest. And so the tallest number there in this one is 163, no, 165. And we're going up, so we get 168, so 172. Yeah, 172 is the tallest person. So let's put this here, 172. That is the tallest person there. Let's put that in. So 172, and it is a male. So the gender is male. Okay, so 172, and it is a male. Let's put that in real quick. All right, so the age is age 17. So the age here is 17, and the gender is a male. Gender is a male. All right, and that height is 172. Okay, the actual state the age and gender. Now, the next part of the question is using the data from table 1 and table 2, calculate the average height of the 15-year-olds. So the 15-year-olds, let's go where the 15-year-olds are, and it's a show working. So I want to find the height of 15-year-olds. So in your graph, let's do the females first, if we have any 15-year-olds right here. So we have 15-year-old right here. Let's put this in green. So there's one right here. All right, so that's 150. There's a next 15-year-old right here. That's 160. Okay, let's go to the next 15-year-old because we want all of them. Didn't say for male and female, said just for 15-year-olds. And so there's one here as well, and there's one up here as well. So working with only 4 persons. Yep. Okay, so one is 160, 158, 160, 150. Okay, so there are 4 numbers there. All right, so let's quickly jump into that. All right, so let's do it real quickly. All right. So now to get the average here again is 4 numbers. So 160. So what you're going to do here again is going to be 160 plus 158, and then the one of the female again was 160. So 160 plus 150, 150, and that will give us all of that together, give us 162. No, 628. Not say 162. 628. And then now this will divide it by 4 because there are only 4 persons. All right, and then we divide 628 as well by 4 persons. Okay, and then this will give us a certain number. All right, so divide 628 by 4. you get one, so this is going to equal to 157. And this is in centimeters. All right, let's put our lines in. So we have a line here to show denominator and numerators. All right. All right, so that will be our answer. Okay, great. All right, let's put a little bit up more. Great. All right, so that is us for that question right there. Let's jump into the next question. And so this question said, use the data from table 1 and table 2, draw line graphs of average height against average for males and females. Draw both lines on the same axis. All right, our set of axes. And so what I want to point out here, just to quickly go through this, that there are a number of things you have to do first. Let's go to the graph. I'll draw the graph, right? I drew the graph. And so what I want you to notice in this, you'll have a number, like for example, the 15-year-olds, you have more than one person on the same gender. So what you have to do, you have to find the average for those. So a quick way to look at it in terms of average, just kind of do that real quickly at the side right here. And so to find the average, what you'll want to do is go through each number. And so, for example, 12-year-olds, right? For 12-year-olds, you only have 142 because there's only one person there, right? And then you want to go for the 13-year-olds. So the 13-year-olds, they will be 13. You have 152. There's only one person again in 13-year-olds, so 152. Okay. And then you want to go to the 14-year-olds, and the 14-year-olds, there are two of them, which is 156 and 150. Add both numbers, divide by 2, all right, and you will get 153. So this is 153. Okay, you want to go to the 15-year-olds, and then for 15-year-olds, to find the average again. 15-year-olds is two persons here, which is 160 and 158. Add up both numbers, they get 159. Okay, yep, 159. All right, and then you go to the 16-year-olds, and then for 16-year-olds, you check how many 16-year-olds are here, two of them. So you have 168 and 168. So that round off to be 168, right? Yeah, 16-year-olds, 16-year-olds is 168. So it's 168 and 170, right? And so the average for that to know would be 150, 169. Okay, yep, 169. And go for the 17-year-olds. How many we have here? We only have one, says us 172. Okay, so there's no average for that, 172. All right, and then the last age, which is 18. And you go for the 18 for that. Again, is only one person 18, so that is 168. So you'll work with these numbers for males, okay? And then for females, now what you'll have done here is do the same thing in terms of average. And so again, you go for the 12-year-olds, and then you look for 12-year-olds inside of the chart, and there are two of them, so 143 and 152. And so average of that will give you 142. Okay, and go for the 13-year-olds. Here again, you have only one person. Says what? No, that's 13-year-olds. All right, so for 13-year-olds, you'd have 143. There's only one person is 13. All right, so one person is 13 there. And then you go to the 12. For the 12-year-olds is 143 and 144. That is 147. That is 140. That is 12. Yeah, 147.5. Right. So let's make a change with this. So this was 147.5. That's the average for that. And then we could go to over 14-year-olds now. And let's see how many 14-year-olds we have here. We have one 14-year-old. So that's just 144. Okay, so that's 144. Over 15-year-old. Let's see how many 15-year-old females we have here. We have two. And so it's 160 and 150. So that is 158.5. 158.5. Right. And then you'll go to your 16-year-olds there for females. And so for female 16-year-olds, you have 2 of them, which is 163 and 154. Average of that is no, I'm doing this thing wrong. So 155, okay? And so this here would be 1558.5, and this will be 155. All right, great. And so the next age we have here, we do not have any 17-year-olds, so we cannot account for that. So go to 18-year-olds. And our 18-year-olds right here is 165 and 156. And that will give us average here of 160.5. All right, so that will be an average for each age for male and female. So we'll plot this in the graph again. I just skip through all of that and just show you the plotted graph. All right, so save some time. And so this is a graph that I plotted. I use the blue for males and the red for females. All right, and so we'll get into this now to answer the questions. All right, so the first question here. So again, just point this out. You label it the axis. Please make sure you label them with the proper units. Again, please make sure you do that. Also, what is important here, because of the length of the graph, what I have to do is to kind of break the graph a bit. So let me just put in how I break the graph here. So I start at 110 there, and I also have to break the graph on the X as well, because they will not fit so properly. Because to start from age 1 going up will be difficult, right? So I kind of fit them on the graph like that. All right. I'd prefer a bigger graph so we could plot them on it much better, but it is what it is. We have to just work with what we get, and you plot your numbers like that to make them even out, okay? All right, so the first question here now, it asks, state one age at which the average height of males and females is the same. So if we go back to your graph right here, looking at where the line actually meet, and so the lines, they meet right here. Let me kind of put an highlight right here. So they're all right, so put this back. Okay. All right, so let me take this off first. Get this on. I wonder if it could work like this. I'm gonna start from right here. And so I'm gonna come in like this. And so you notice both of them will meet right at that spot, right? So if you go across, if you come across here, right? And to where the line meets, okay? And then you go straight down, then you kind of have your idea exactly, all right? So again, you could follow the center of this line kind of broad because of how I'm zooming it. And again, I have to do that to ensure that I don't mess up the rest of stuff, okay? All right, so yes. So again, you check where the both lines meet, which will be here, okay? So that's where both lines meet. And so you can just look at both lines from the X and Y axis, and you get in terms of the number of the height, the value of height, and also the age. All right, so let's now get into it and put our answer there. So going across, you get in terms of age on the x-axis, what you'll get there is 12.2. So it'll be 12.2 years. Okay, so they went there about 12.2 in terms of number of years. And then in terms of height, that will be 144.5. So 144.5. That will be the average height when they both are at the same age. Okay. All right. So part 2 now state what conclusion can be drawn about the height of 16 to 18-year-old males when compared to 16 to 18-year-old females. And so based on the graph, by looking at the graph, you'd realize that at the 2 ages at the last point right here, the males, which is in blue, it is higher, generally higher than females, okay? So I can simply say right here that 16 to 18-year-old males are taller than females at the same age, okay? At the same age, yep. All right, so that could be a conclusion right there. All right, so let's now jump to our final question here. And so he said, explain how a farmer could use the materials listed below to determine the average water content of the soil. And so he said, use the materials below to design an experiment. So this would be like a skill D, all right, to answer the question. And so It said the materials here, we have soil, we have Petri dishes, we have balance, we have oven, we have desiccator, we have tongs, and we have thermometer. All right, so here now it is a whopping 10-mark question. And so step by step, let me just run through this with you real quick. So the first step you want to do here, I could put numbers. Okay, let's put numbers. All right, so the first step you want to do is to dry and weigh the Petri dish. Normally do not use Petri dish for this experiment. You use like a metal container, all right, or anything that can withstand heat. That's the thing that you use to get it. But first you want to collect your soil in the Petri dish. You want to weigh your soil in the Petri dish and so on. So here you're going to dry it out. You're going to make sure you dry out the Petri dish. You're going to dry and weigh, okay, the Petri dish, okay. So the Petri dish must be dry and weigh. The next thing you want to do here, so step 2, what you want to do in step 2 is to place the soil in the Petri dish and weigh them. Okay, so you want to place the soil, place the soil in the Petri dish and weigh both of them together. Okay, all right, just to make a note right here, I think I'll put this in afterwards. Matter of fact, let me do it right now. This here will be our mass 1. Okay, let's say mass 1. Say this will be M1, right? And then this here will be our mass 2. So let's put that here. So this will be mass 2. All right, just to make a note of that, let's use lowercase m. So mass 2. Okay. And then the third thing you want to do after you have done that is to place the soil in the container or place it in the oven. So you're going to place the soil. Place the soil in the oven. Okay. All right. And you can place it with the container. But what you're going to ensure is that the container put no lid on the container, right? So with the container, put without lid here because you do not want any lid on it at all, without any lid. Because the reason why you don't want any lid on it, you want the water to be able to evaporate when it's in the oven, right? All right, so this will be part 4. And just to make a note here, I kind of miss it, leave it out. You make sure you mention to weigh it with the balance. You're going to use the balance to weigh here. So let's put it right here. But please remember, you need to weigh with the balance because you need to include all of the apparatus in your method, okay? And that's why they put it there, okay? So with your balance. All right, so great. And so for part 4 now, what you're going to do is heat the soil. So you're going to add heat to the soil. So heat the soil. Okay, heat the soil. And check the temperature or measure the temperature and check the temperature. All right, and check the temperature to ensure, you want to ensure that the heat is at least the boiling point of water, okay, to ensure that the temperature reaches boiling point. Because if it's not at boiling point, then water will not evaporate, right? We're in boiling point of water, okay, which is at least 100 degrees Celsius. You're going to make sure you heat it above that as well. All right, so go above 100 degrees Celsius to ensure that all the water will be evaporated, right? That's why the thermometer is important, okay? So you're going to check the temperature with the thermometer, so include that in the statement as well. All right, so step 5, what you're going to do is to remove the soil from the oven. So you're going to remove the soil from the oven. All right, I'm going to talk about what a desiccator. I didn't mention what that is, but I'll talk about it shortly. So you're going to remove the soil from the oven. I'm going to make sure you use with the tongs because, of course, you don't want to burn yourself. And so they also want to see exactly how you'd use these things because they want to make sure they follow safety procedures and so on. All right, and so they're looking out for those type of stuff. All right, so let's go to our next point here, or 6th point. So after you remove the soil from the oven, you want to do something next with it. So you're gonna place now the soil. All right, you're gonna place the soil now in the container, and you're gonna measure it. You're gonna place it in the desiccator at this time. Okay. All right. So so 6, you're gonna place the soil. So place the soil, which is a warm soil or hot soil. Place the hot soil in the desiccator. All right. So place in desiccator until it is cool. Until it is cooled. Okay. So once it is cooled, what I want to do next here now is going to remove the soil and now remeasure it. Okay. So you're going to remove the soil and remeasure it. Okay. And remeasure it. This new measurement now, and you're going to measure the mass using the balance. So this we'll call it mass 3. Okay. So let's put an asterisk there. So this is now mass 3. Okay. So we have 3 masses. Okay. The empty container, the mass with the container with the wet or moist soil, and then we have the dry soil right here. And then what I want to do next is to calculate the water content. That's the 8th thing I want to do, is to calculate the water content. Okay. All right, but how would you calculate the water content? Remember, we have 3 masses, right? We have let's put the 3 masses here for you real quick, right? So let's put it right here. Let's put this piece in red, so you know, kind of create a little difference here. And so here, let's put this in red. So we'll have the empty container, which is just the Petri dish. So we have the empty container. And remember, we have this as mass 1. So let's call this our mass 1. And then we have the mass 2, which is the soil, which is a moist soil. Let's call it moist soil. So the moist soil or wet soil, whichever it is, plus the container. Okay. All right. So plus the container. And that is our mass 2. Okay. Mass 2. And then we have next, we have the last mass was the dry soil. So this is now the dry soil. Is after you place in the desiccator. And desiccator is a airtight container that will prevent moisture from going back into the soil, right? Okay, so this will be the dry soil plus the container. Okay, so this, all right, and so we call this now our mass 3. Okay, so this is our mass 3. All right, so what we'll do, how to find the mass now of the water is kind of pretty much easy right here, because if you have the dry soil and the moist soil with container, all you need to do is to minus M3 from M2. Okay, so here now to find the water, then put this probably in here. So I'm gonna put this in a different color. Let's put this back in blue. All right, so what we're gonna find here now is the water, or the mass of water. So let's say mass. Okay, mass of water. And so the mass of water here now is equal to M2 minus M3. Okay, so it'll be the moist soil in the container minus the dry soil in the container. Okay, so minus M3. And what you can do as an interesting calculation again is to calculate something even different. You can calculate the percentage water content. So you can also calculate the percentage water content as well. And so how do we do that is a calculation that you, okay, look at the difference in terms of the masses. And so this will be mass 2 minus mass 3, okay, times 100% multiplied by 100%, all divided by mass 3, divided by mass 3 minus mass 1. Okay. All right, so that will be your calculation there. Let's put just a red line right here to separate our numerators from a denominator. Okay, let's see if it will work. Maybe this won't work here. All right, but this is a division. Yeah, awesome. It will work. Excellent. All right, ignore the curved line, but yeah, that will be the percentage of water content within the soil, or the water content that was removed. All right, so great. So you can find it in terms of mass, or you can find it in terms of percentage. Okay. All right, so this is the end of our paper 5 review. Again, I hope you get some chance to really score some good grades, read through the content. Again, if you know the content right throughout the course, right, you still will be good, because remember, they will test different things on different content that you have done in paper 1, paper 2, and paper 3. Anyways, all right, so know all the content is always a good way. Okay, so take care. Do well. All right.